Only difference from today compared to yesterday is now we're graphing systems of linear inequalities. Shh. Again, voices need to stop and attention should be up here. When we graph a system, so think about when we are graphing systems like just linear systems and not systems of inequalities, we would graph two lines, right? And this was part of your quiz. This will also be part of your test. You'd graph two lines and you tell me where they'd intersect. You'd say these intersect at x comma y. And so most linear systems, okay, of equations only had one solution. Okay, we also looked at lines that were parallel where we had no solution. We also looked at lines that were the same and intersected infinitely many times and had infinitely many solutions. When we start to graph systems of inequalities, remember that we have that shading involved. So already there's a lot of solutions. What's different about today compared to yesterday is we're going to shade just one section that makes both inequalities true. Okay, and so that's what gets kind of confusing is where is that one place that we're going to shade that makes all the inequalities true? And that's what this is saying right here. Okay, so when we graph system of linear inequalities, we're going to graph and shade each individual line just like we did last time. The solution to the system is where the shaded regions of the two inequalities overlap. And we must follow the same rules for graphing individual inequalities. So we're just going to jump right into it. Okay, so number one here. Okay, first off, remember, I don't really care about the inequality sign yet. I'm graphing the line, x equals 4, but I'm doing it with a dashed line. Okay, that's what the inequality symbol is telling me. The points on the line do not make the inequality true. So x equals 4, that is a horizontal line where every point on that line has an x coordinate of 4. Then I'm going to do the same thing with y being greater than or equal to 5. I'm going to graph the line y equals 5. And that's going to be a horizontal line where every point on that line has a y coordinate of 5. And so what ends up happening here is almost always when we put both sets of lines or both lines on a graph, we end up getting 4 sections, okay, if they intersect. We are only going to shade one of these 4 sections. So the shading we need to wait until we've said, hey, this is the one section that makes both of the inequalities true. So now to figure that out, we do the same thing we did yesterday. We test a value. So we're going to test 0, 0, and we're going to do this for both lines. So let's first do it for the x being less than 4. So I'm going to test 0, 0. And when I plug it in for 0 being less than 4, I get that that's true. So what I've just done is I've narrowed down the 4 sections to now 2 of them. I need to shade one of the 2 sections to the left of the line x equals 4. So we are definitely not shading to this right side. And that's why I use these arrows. It's a way for me to kind of figure out, okay, it's either this top left section or the bottom left section. And then how we're going to figure out which one it is for that, we're going to test for the other line. So test 0, 0. I get 0 is greater than or equal to 5. That one is false. And so what that means is I need to be above the red line. And so the overlap, it's where we see, or where it works for both inequalities here. So we need to be left of the vertical line and above the horizontal line, which means the part or the region that makes both inequalities true is this top left section. Okay, so I don't want you doing any shading until the very, very end. Use those arrows to figure out where you want to shade and then only shade one section, because when you start to, especially if you're using a pencil and you're trying to overlap, it's really hard to see what you're calling that overlap section. So just use the arrows and shade one particular section. Okay, everyone do 2, and then we'll do one more together, and then probably have you do the rest on our own or inner groups. We really don't have that many examples today. Okay, would everyone do number 2? Again, I'll ask that you try right now. See what you come up with. Sorta. Yeah, we definitely get something weird that happens here. Okay, one thing to notice is that these lines are parallel, right? They're both x equals a number, so they're both just vertical lines. And then for the first line, x being greater than 4, well, we need a shade to the right of that. Okay, when I test 0, 0, I get that that's false. So I'm shading the side that does not include 0. And I get the same thing to happen with the other line of x being less than or equal to negative 2. Okay, when I plug in 0, I get a false statement. Okay, so again, I'm going to shade away from 0. So in this case, is there any place that overlaps? Okay, where we get, or that makes both these inequalities true? Any overlapping here? No, right? There's not anywhere that I can shade. And what this is saying, if you think about what this means, can anybody list a number or an x value that is both greater than 4 and less than or equal to negative 2? No, those numbers don't exist. Okay, so just like when we graph a system of linear equations, inequalities can have no solutions. This is one of those cases. Nope, there's no shading. Okay, no shading at all. Okay, remember what the shading is telling us. The shading represents all the combinations of x and y values that make both inequalities true. And that both part is really important here. Okay, if it's just one of them, we don't have solutions. It has to work for both of those. Okay, so here there's no values or no points on this graph that makes both of our inequalities true. Okay, let's do number 3, and I'll have you all do number 4. And I'm going to do this left line in red. That is in mx plus b. So negative 8 is the y-intercept. So I'm going to put a dot at negative 8. And then my slope is 4, having me go up 1, 2, 3, 4, and right 1. Up 1, 2, 3, 4, right 1. Up 4, right 1. Up 4, right 1. That should be a dashed line, because of it being just greater than and not greater than or equal to. The other line is also in slope-intercept. So 5 is the y-intercept. I'm going to put a dot at 5. My slope is negative 1/3. Tell me to go down 1 and right 1, 2, 3. Down 1, 1, 2, 3. 1, 1, 2. I'm going to go up 1 and left 1, 2, 3. All right, this should be a solid line because of the or equal to in our inequality. And once again, we have 4 different sections. And so we need to figure out what is that one section that works for both these inequalities. So I'm going to start with the left inequality and testing 0, 0. So I get 0, is it greater than 4 times 0 minus 8? 4 times 0 is 0, so this is 0 is greater than negative 8. And that's true. So in relation to this red line, we want to shade the side of the red line that has 0, 0, which is the side to the left or kind of above that line. Okay, so we are for sure not shading these two sections. It's either the top left or bottom left section. To figure out which one exactly, it all depends on what we get when we test 0, 0 for the other line. So now I'm going to test 0, 0. I get 0 is less than or equal to negative 1/3 times 0 plus 5. This is 0 being less than or equal to 5. And once again, I get a true statement. Since this is true, I'm going to shade the side of the black line that is including 0, 0, which is below this line, and thus the overlap is this bottom left section. Okay. Any questions here? All right. I'm going to ask this. We all do number 4. Number 4. First off, I want to change one thing about 4. This happened on our test too. If you remember, I had you all change, or on the quiz, I had you change one of the equations. If you look at this second equation here, this is point slope form. It's just that the y coordinate is showing up in a different place. So where we recognize that y coordinate as being added or subtracted to the y. So when it's just out here at the end, I can add 5 to the other side and make this y plus 5 is less than 1/2 x minus 2. Okay, now it's in a point slope form that we recognize a little bit, hopefully more clearly. So that y coordinate is -5 of your starting point. For this equation, you're going to have to work to get y by itself. So you got quite a bit of work to do on number 4 here. Okay, let's give you a few minutes to do this. We'll check our work. And then we'll probably do the last one together and then get you a little bit of homework time. Yay! Another weird thing to happen again. Hopefully we recognize lines are parallel. And that you end up having to shade above one line and below another. And thus there is nowhere or no set of points that make both true. And thus there's no solution again. Now, just because the lines are parallel, that is not the reason why this is no solution, right? It's because there's nowhere that we can shade that makes both of the inequalities true. Okay, so we have to do the actual testing. The parallel part is not right, why it's not no solution. Okay, let's just do one more, and then we'll call it good. I'm not even sure what time we get out of here. These schedules are always hard for me to remember. 19. So let's just do this last one together. That way we can get you a little bit of time to do some homework here. All right, let's do 6. That way we can talk through the standard form because that's, again, the one equation a lot of students are still having trouble with. All right, so 2x minus 9y being less than or equal to 18. I'm going to work to get y by itself. So I'm going to subtract 2x. I get negative 9y is less than or equal. You know, I don't even care about the inequality symbol. Let's just make it an equation just so that we're not confused by it. So I'm going to add or minus 2x, so negative 9y equals negative 2x plus 18. Then I'm dividing every single thing by negative 9. And I get y equals negative divided by negative is a positive, so that's 2/9, but positive 2/9, and then minus 2. So we have y-intercept at -2, a slope of 2/9, so up 2 and right 9, and then down 2 and left 9. And then because of this being less than or equal to, I need this to be a solid line. And if you want, you can actually test right now and just figure out where we're going to shade. I still would prefer that we use arrows and not any sort of actual shading just so that it doesn't get too confusing. So when I test 0, 0 here, again, I'm going to plug that into the original. So 2 times 0 minus 9 times 0 is less than or equal to 18. So that's 0 is less than or equal to 18, which is true. So that means we want to shade the side that includes 0, 0. And now for our last line, this line starts at 2, comma 5. So that first point, I'm going to go right 2 and up 5. And a slope of negative 1/2 has me going down 1 and right 2. Down 1, right 2. Down 1, right 2. Down 1, right 2. This line is a dashed line. And then we just need to figure out where we're going to shade compared to this red line here. So let's test 0, 0. So 0 minus 5 is that less than negative 1/2 times 0 minus 2. Negative 5 is that less than negative 1/2 times negative 2. Well, negative 1/2 times negative 2 is a positive 1. And negative 5 is definitely less than a positive 1. So this is true. And thus we're shading towards 0, 0. And the overlap is kind of this left section. Okay, well, we will stop there.